Welcome and hello. This is a video exercise in HEC ResSim, and in this exercise, we're going to be using the Monte Carlo analysis in the Monte Carlo alternative type when running a compute. All right, I have ResSim up on the screen here. We're going to first build a reservoir network and then get started on those Monte Carlo simulations. Let me go ahead and also put up the question that we're going to be answering once everything's built and we're ready to start testing. The question is shown here. Find the smallest maximum release from the controlled outlet in CFS value that will prevent the uncontrolled outlet from spilling more than 3000 CFS. So clearly there's more information that needs to be provided for us to answer a question like this, but this question will be used for us to direct our search once we get everything up and running. All right, so let's go ahead and get started. First things first, let's create a watershed. File, new watershed. Make sure you're in this watershed setup module here on the top left. Then you can create a watershed. So I'll call this is my watershed name. And then select the location you want your watershed directory to be saved to. And click open, select your units, English or SI, and then your time zone, and then OK. And OK. All right, the watershed has been created. I'm going to zoom in, select the stream alignment tool, hold down control, and then start clicking from upstream to downstream. I'm continuing to hold down the control key. And then just before my last click, I will let go of the control key and give that stream alignment a name. I'm going to select the computation point tool here and then single left click to add a computation point. This is near the upstream end. Now I'll add a reservoir by clicking the reservoir tool and then hold down control and then a single left click on the stream alignment at the upstream end of the reservoir pool, and then another let go control, and then another click on the downstream end, which would be the dam face location of the reservoir. I'll call this reservoir 1, and then for good measure, I'll add one more computation point at the downstream end. All right, watershed configuration editor. This is how we create a configuration. I'll go configuration new, and then I'll just call this config 1 and a time step of 1 hour. It's not used by ResSim, but need to hit apply and OK anyway. The configuration has been created. That's good. And we're good. I'm going to go File, Save the Watershed, and then select the Reservoir Network module from this module dropdown. First thing to do here is to create a network. So I'm going to go up to Network, New, and then I'll just call it Network 1. It'll be our only network. And then this is also important to select the configuration that we just saved here for configuration, and then new. Okay, here's my configuration. The text is really large for some reason. All right, I'm going to connect the network by clicking the reach tool here, holding down control on the upstream junction point, and then let go control, and then another click at the next downstream junction. And then go ahead and do that for all your reaches, and we are connected here. So I'll go network, save. I'm going to specify a inflow here at the upstream junction. This is junction CP1. So I'll select the local flow tab, and then I'll just type in inflow at CP1, factor of 1, apply, and OK. All right, so now we see this upstream junction CP1 has a little blue circle around it, indicating that there's inflow associated with that junction. All right, now let's go ahead and edit the reservoir. We have to give it some information too. Here's the pool geometry. I'm going to paste in the pool geometry here. So the volume is 100,000 acre feet at top elevation of 1500. So here's the dam face. I'm going to just say 1500 for the top elevation, and I'm going to make up a top length, apply. Next, I'm going to create a controlled outlet, and then I'm going to paste in the data there. I'm going to say there are 3 gates. And then also I'm going to create an uncontrolled outlet here. It will have an invert of 1480, and then I'm going to define the outflow versus elevation using this table data here. So its invert is 1480. It has a max release of 8000 CFS at the 1500 foot elevation. All right, so this is the plot of release. That's great. Okay. Next, I need to define the inflow at this CP1 junction. So to do so, I'll start and go Tools, HEC DSS View, and then I need to create a DSS file. So File, New. I'll call this time series data.dss. Okay, the file's been created. Now I'm going to go data entry, manual time series, and then the path name parts I'll say is project, location, flow. Okay, I'm going to select 1 day because this is a 1 day time interval on the inflow that I'm inputting, and then CP1. Then the start date will be January 2023, 2400 hours. Units will be in CFS, and I have saved on my clipboard the actual values. So I'm just going to put the cursor on this first record here corresponding to January 1st, click paste, and then here are the values. Goes down to December 31st, so that looks good. Save, and then I'll show you what those flows look like here graphically. We see 12 months of daily flows with a small peak in late January and then two larger peaks in sometime in March and July. And yeah, so we have maybe an average flow of 2,500 CFS approximately, but the peaks are much higher than that. All right, so I'm going to go ahead and save that. That's already saved actually, and head over to create an alternative. So here's the first all time. This first alternative will be a base alternative. So I'll just call it base, and it's going to be a standard alternative from which I will make a copy for trials for the Monte Carlo analysis. Okay, so I'll call it base. Okay, again, I'm going to leave it at standard for now. For time step, I'll say 1 hour. And then the operation set here. Oh, I still have to do that. Let me save the alternative. I need to edit the reservoir and add my zones. Yep, I forgot to do this. Operation, I'll go ahead and go operation set 1. Okay. And the zones are going to be just the 3 that I'm provided will work fine. Flood control, conservation, and inactive. So the flood control zone will be have a top of 1,500 feet. Conservation will have a top of, this is going to be the guide curve elevation. I'm going to say this is 1,450. Apply. And the inactive will be 1,400. Apply. I also want to create a rule that will be used by the Monte Carlo simulation as the input value, and that's going to be a maximum release rule from the controlled outlet. So add new rule. I'm going to call this max controlled outlet. The value, I'm going to start it at 3,000 CFS, and we'll see what happens with that maximum. And this is going to be based on date, 3,000 CFS, apply. And then we will also add this rule to all zones, apply, and OK. So remember, we still have an uncontrolled outlet, that spillway, that's unregulated. You can't put any rules on those uncontrolled outlets, but the controlled outlet we can, and we've specified a maximum of 3,000 CFS. All right. Back to that alternative. Now we have an operation set. We can finish this up. There it is. And the look back data, we're going to go ahead and say 1450 is the look back pool elevation, and then the look back release and spill from the controlled outlet and uncontrolled outlet will be, I'll just say it starts at 3,000 CFS, which is the max, and then the uncontrolled outlet will start at 0 because the water surface elevation is below the invert. So that makes sense. For time series, this is the last thing we have to do here. We're creating our standard alternative here, this base alternative. We'll select CP1 as the record we want to populate. Click this Select DSS Path button, and then navigate to our time series data.dss file. Select the record that we created, those daily flows for 2023, and then set path. So that has been assigned right there, and we'll go ahead and hit save. All right, so we are done with the alternative. We're done editing the network. I'll go ahead and save that. Next, let's select this simulation option from the module dropdown. Now, let's create a simulation that includes our alternative we just created. Simulation 1. This is for, again, the whole year of 2023. So I'm going to go, I'll start it on January 2. The look back will start on January 1st. And then the simulation will end on December 31st. At the end. Okay. And now I'm selecting our base alternative down here and clicking OK. Our network's over here in the main display. We're ready to simulate. Again, this is not Monte Carlo, but we're going to look at the results and then start building some Monte Carlo alternatives to answer that original question. All right, so that ran. That looks good. Let's take a look at the plot. So what we have here is the water surface elevation in the top plot. It goes well above the guide curve elevation of 1450 because we have that maximum release rule of 3000 CFS, which you can actually see in the bottom plot here. Highlighted right now in the bottom in this black line is the inflow. So we've seen this shape before, but then now highlighted in green we see the release from the reservoir. So this is the outflow from the reservoir pool. And at 3000 CFS, we do see that line plateau at a few different places because the maximum release is through the controlled outlet is taking place. Now we're seeing that this green line is the total flow. It's the controlled outlet release plus the uncontrolled outlet release. And when it's above 3000 CFS, that's the contribution from the uncontrolled outlet. Find the smallest release from the controlled outlet in CFS value that will prevent the uncontrolled outlet from spilling more than 3000 CFS. Okay, so what we can't really glean from this is how much release is that coming from that uncontrolled outlet. We could eyeball it actually because we know it's going to be this maximum value of maybe 600 minus 3000, so that would be about 3600, which means it's too high. So we need to increase the maximum allowable release from the controlled outlet above what it currently is of 3000. So we know it's more than 3000, but rather than just kind of try a bunch of individual records, I'm going to use the Monte Carlo alternative to try a bunch of records, and then hopefully we can quickly and easily zoom in on a more accurate answer. I'm going to right click and create a trial. Now, for the name, I'm going to call it Monte Carlo. And then let's just create a wide range, something like 2000 CFS to 8000 CFS. 8000 is most likely too much, but 2000 we know is also a little bit not enough. So let's go ahead and just give that a shot and see what happens. We got to make some edits, of course. So the alternative editor is going to be type Monte Carlo. And then let's click on this Monte Carlo tab, and we need to specify our input, output, and MC controls. Starting with input, I'm going to click add. Then I'm going to select reservoir rule parameter, and then next. This is our only reservoir rule right here for reservoir 1 for the controlled outlet. 3000 CFS is just what it was originally assigned, but we're going to change that. And then, yeah, we'll use those values. Now, what I want to do here is use the uniform distribution, and I'll just say 2000 up to 8000, like I labeled this alternative or this trial to be. And I don't need to do a minimum or maximum because I've sort of already specified that here. And yeah, just a constant PDF. Therefore, the CDF is a linear. Okay. The output variables I'm interested in, I'm going to go ahead and add a few things here. Let's go with reservoir pool outflow. Now, this is for both controlled and uncontrolled outlets, but I'm just curious. So let's go ahead and add that. And I'll use this output variable for convergence. So I'll check that on. I'm going to make this a little bit wider. Okay. And of course, we do need to add the controlled and the uncontrolled outlet as well. So here's controlled outlet. Here. Using the filter might be a little easier. Controlled outlet flow. I'll just use it as is. And then the last one, which is really the most important, is that controlled, uncontrolled outlet. And then here is the flow. Next, finish. Okay, save. And then MC controls is the last one. I'm just going to set it at 100. That's fine for what we're doing. And then this radio button here will clear previous results. So that's also what I want to have done. All right, so there we go. Let's go ahead and click save and then run this record. It will be 100 iterations, and then we'll check out the results. So it's running through right now. It's only on number 10 right now, so this might take a little while. 15, 18, 20. What you're seeing here is it's having to convert that daily flow to an hourly flow because there's 1,440 minutes in a day, and it's converting down to 60. So it's just assuming that the flow rate for a day is the same at each individual hour. Okay, there's 60. Okay, so that's done. 54 seconds of runtime, not too bad. And then let's go ahead and take a look at the report now. This is base one, so trial one. And then let me take a look at the histogram. Okay, pretty good spread between 2,000 and 8,000. Now let's actually look at the report. Okay, that looks good. So what I'm seeing in this top plot is the maximum release from the controlled outlet. So 1 percentile was as low as 2,096. That would cause huge releases from the uncontrolled outlet, but then large allowable maximum release from the controlled outlet of 78.95. That would probably greatly reduce, perhaps down to zero, the required release from the uncontrolled outlet. All right, so we'll return to this table in just a minute because I want to look at the other results. Here is the total flow from the reservoir, and I'm keeping track of the maximum value here, not the minimum or mean or anything. And then we have the controlled outlet, and then the one I'm most interested in here is this uncontrolled outlet. So as mentioned before, when the maximum allowable release from the controlled outlet is high, we're going to have this situation down here where there's zeros because there's no need to release water from the controlled outlet. The water surface isn't even going to get high enough to get above 1480, which is the invert for that spillway. But what I do see here, I'm looking for 3,000 CFS, and I'm seeing 2,800, 30, 700. So it's probably going to be in this range here between like the 75 percentile and 90 percentile, which corresponds to 10 to 20 percentile, because this is sort of an inverse relationship between the maximum allowable release through the controlled outlet and then how much this uncontrolled outlet is going to be spilling. So just remember 10 to 25, and then I'm going to scroll back up here to the input data. And then so 10 would be a 2843, and then 25 would be 3,600. Go. I don't think we need to go quite as low as 28. Let's go from 3,000 to 4,000 and see what happens. So originally our first trial was a 6,000 CFS range. Now we're narrowing it down to just a 1,000 CFS range. And we know it's more than 3,000 anyway, based on our standard trial, which is the first one. So yeah, between 3,000 and 4,000, I think would be a good range for trial number two. So I'm going to return to the simulation tree, new trial. It's going to be based on that first Monte Carlo trial. And then I'm going to call this, just describe it with the range itself, 3,000-4,000. Okay. And then I'm going to uncheck these and then edit, alternative editor, Monte Carlo, input variable. Now, unfortunately, I've tried this before, and if I click, oh, it worked. Okay. Okay, that's great. That did not work when I tried it before. So all I have to do is change 3,000 to 4,000 here. I spoke too soon. That looks good. And then finish. And then let's go ahead and save. And I don't really need to wait for 100 trials. That took a little bit too long. So I'm just going to, yeah, wait 500 trials. Go 50 trials instead. And then if we need more iterations, then I can do that. But 50 is probably good. Okay. Boom. And good. And let's run this trial number 2 now. Okay. Trial number 2 is done. And let's take a look at the report. Let's confirm that the histogram used the correct range. It did. For some reason, it was very popular to use some larger numbers here, so I need to be careful with that when looking at the results. Might be worth even running the trial again based on that, but let's see what we got here. I'm going to go all the way down to the uncontrolled outlet right away. And again, I'm looking for 3,000 CFS is kind of my range. So I'm seeing the 50 percentile is 2660. And then the 75 percentile, 3116. So that would correspond to 25 to 50. So if I head back up to the inflows, 25 and 50 rows are right here. Okay, so let's see. If I could create a new range that's less than 1000 CFS but includes these two numbers, what if we do something like 3200 CFS to 3600 CFS? So that's now a 400 CFS window, which we're running simulations on to determine where that 3000 CFS threshold lies for the uncontrolled spillway. All right, so close this, right click, let's go new trial, and then MC 3200 to 3600. Okay, and then I'm going to edit alternative, go to the input variable, edit. Oh, that's great. Yeah, okay. 3200 to 3600, and then finish. Okay, and save the alternative. And I close that alternative window. And then let's go ahead and run this trial now. Okay, that completed. So I'll click close. And then let's look at the report. Search for that uncontrolled outlet results table for 3000 CFS. This is not what I wanted. Trial 3, and then output report. So yeah, it's really close to this 50 percentile. I keep we're getting really close to that. So it'd be, yeah, 25 to 50, closer to 50. So let's do one final trial. So here's 25 and here's 50. We're definitely narrowing down the range. I want to kind of be conservative. So I'm going to go 3300 to 3500. This fourth and final trial using Monte Carlo will be just a 200 CFS range. Okay, last time. New trial. And okay. Right click and edit run. Alternative, edit. That looks good. So I'm going to click finish. I do actually want to run 100 this time. This is the final time, just to get a little bit more, a larger population, more iterations in this compute. Okay, and we're saved, and I'll go ahead and run this Monte Carlo analysis here. Okay, that just finished up. So I'll click close, and let's go reports. I'm going to take a look at the histogram first. Okay, pretty even spread between 3300 and 3500. Reports. Let's take a look at the output report. Zoom down here to the uncontrolled spillway. Yeah, between 25 and 50, but closer to 50. So 3400. Let's go ahead with 3400 and see what happens. So what I want to do on this final trial, not use Monte Carlo, but actually just change the release to 3400 and create a new trial. And then we can actually look at the plot and see what it looks like there. So instead of a population of values with multiple iterations, it's just going to be one single compute. So for the trial name, I'm going to call this standard and then 3400 CFS. Okay. So let's go ahead and edit that trial, and we'll go with alternative type. In run control tab, we have to change it back to standard, and then, okay, save that, close. And then in reservoirs, I'm going to change the operations. This is not going to be 3000 anymore. It's going to be 3400, and then apply. Okay. All right, let's run that. Of course, it's nice and quick. And then let's take a look at the results. Okay, so this plot looks similar to what we saw before. A little bit different because now that maximum release from the controlled outlet's 3400, not 3000. So that should reduce the maximum release from the uncontrolled outlet to much closer to 3000. We don't see that on this plot here, but we can get that data by going to HEC DSS view. Let's select the uncontrolled outlet, and then lots of data still. Okay, so it's monthly. And let's see, this was trial 5. Yes, this is going to be the flow. Okay. Yes, so these are the 12 records, one record for each of the 12 months. It's only going to be interesting at 1 month, which is this month right here. It's right at 3000. It's March. So I'm just going to grab the March data. Here it is. And then let's plot it. Okay, so we're just over 3000 CFS. Okay, I guess it's maybe 40 or 50 over 3000. Tabulate. And then when is this? This is on March 25th. in the morning. Yeah, okay, so it looks like the maximum is about 3,047. So what I would do in that situation is increase the maximum allowable controlled outlet release a little bit more until this gets down to 3,000 CFS. But this problem was just academic in general to kind of understand what sort of problems we may want to solve in the real world, but and also how to use ResSim to help us get to those results. So what we did here is we used ResSim, specifically the Monte Carlo analysis tool, the Monte Carlo alternative type, to create a population of different values for that maximum release through the controlled outlet as a way to more quickly evaluate the system and find a specific solution, like we did here with what is close to the correct solution in this final trial here.